Hi everybody, we have a pretty exciting P3 to look at today. It is lesson 4 and the student was in the 12 p.m. discussion on I believe Wednesday, and we'll see in this example what it's like to hit a wall, so to speak, and not to be distressed or discouraged in any way, but determined in getting the correct answer. So let's go ahead and view this. So here, student sees one question and is ready to solve the problem. So now we can see the entire landscape of the problem here, and it seems like the student is reading the question, and we can see if I stop the computer for a second, it's asking us to determine the frontier orbitals involved in step 3 of the reaction. And there's a figure. So really it's good to focus on what you're looking for, and I believe the student also is able to see it as now as going over to the figures to look and see what the governing FMO analysis is. As we wait for the student to open up figure 2, let's kind of just talk about it. We can see the red arrow and the blue arrow. So those are the differences that we're going to really focus on. And looks like the cascade of reactions begins with the electron density at the tail of the red arrow. And the student at this point is just taking a moment to let it sink in and not really jumping to any conclusions, but trying to visualize it. And at this point has come to a first conclusion. So we have a sigma molecular orbital as the HOMO, and that is correct. We could stop there and just think about if we were to go back for just a second. We don't see a pi bond in that hydroxyl bond there. But we do notice that there are lone pairs and not oxygen. But keep in mind where the tail of that arrow is starting from. So the student was able to point that out. So as we just continue in this, we can see that the student has selected a sigma star, and that is absolutely correct. Pi type overlap. So oftentimes you're going to see intramolecular interactions occurring in a pi type fashion. This is just because of a lack of freedom of rotation. However, it's not to say that the sigma type won't happen. If in fact the sigma type overlap is viable, it's going to happen in that fashion just because of the overall stability of the sigma bond creation. And so now we can see the second set of arrows here. Sigma to A is what the student has selected, and that's absolutely correct. If we just wait up a second here, we can see that the sigma bond here is going into an empty atomic orbital position around carbon, so that carbocation. And I believe this is where the student encounters the first obstacle, and you'll notice that because the student spends quite some time thinking about it. And let's just stop to think about this. The student had confidently put in all of the choices for five of the fill in the blanks. However, there's only one option left, one box left with 2 possible choices. So realistically, you can guess and submit it. Like if you're running out of time, just you've nailed down 5 of the choices. Go ahead, and if you're running out of time, go ahead and just give it your best shot. Don't be afraid to try something. But the student here stays composed and doesn't jump to any conclusions. That is what I particularly appreciate about this performance on this problem. So let's go ahead and see what happens here. At this point, he or she is really thinking about how this is happening overall. He's trying to get a better sense and looking at figure 1. All right, not making any moves yet, which at this point is very admirable, and the determination is quite evident. So we can see here is determined with the sigma type interaction. But we notice that the response is incorrect. But let's just take a second to notice how, the mouse is just staying put. Maybe the student is trying to rethink everything and not just randomly choosing. Although the first 5 choices were chosen pretty confidently and quickly, the student goes back to the figure and is showing a lot of determination to get that extra point, to really answer this choice in the least amount of attempts, which is our goal. And this is where, if you're running out of time, go ahead and choose the other example, the other choice. But because of the systematic approach to this problem, actually the student is saving time by really thinking this through. And one more time, he is just really, imagining the orbitals interact, and that's what we want. That's what we want, and it was really awesome to see that. And we can see here the choice has been selected. The difference was in the pi type interaction, and the mouse was quite ecstatic there. That's the sense of reward. It feels good to approach a problem from a systematic, perspective, and logically, using chemical intuition, coming to a solid conclusion for the answer to this problem. And way to go. And so this is an example of what to do on an exam when you have not gotten the answer correctly on your first attempt, but have thought about it carefully and didn't notice the student did not make any drastic changes. It was just that one interaction, that one type of interaction, and being confident about the other fill in the blank. So once again, this student displayed a confident and determined approach to this problem, strategically narrowed down his possible choices of the answers, and was able to take some chances and was rewarded quite well for it. So way to go, and hopefully we can see this type of performance on future problems and exams. Take care.